Hi, this is Albert from AWB Electrical and Maintenance Services. I'm just doing a bit of a how-to video on connecting batteries. It's actually in response to Vernon boat over on his YouTube channel, Learning by Doing Sailing. Thank you very much for Vernon for tagging me in on that and promoting me. I noticed there was a couple of comments where people were questioning about some of the stuff I did and how I did that, and Vernon wasn't quite sure on how to explain that. So I'm just going to explain a couple of things. One of the questions of note was why 3 cables will run through between the two batteries, and that's my whiteboard here. And I've drawn basically two 12-volt batteries. This can also vary a bit with 24-volt setups. Obviously, you do them in series. But commonly what I see on a lot of mobile homes, off-grid setups, and marine setups is what will happen is a lot of people will do a bit of their DIY electrical. There's nothing wrong with that, each to their own. But what they'll do is typically they'll have the original setup will be, they'll have positive go through the positive loads, then they'll have negative go through to the negative loads, and they'll go, oh, I want to increase the battery capacity, so I'll add another battery in. And what they'll do is they'll do this, and then it's a bit of a dry pen, that one, but it'll do. And then they'll go with this one here and do that. The problem with that is with this battery here, this one here, this is in circuit effectively, and this is paralleled off it, this battery here. So this one's in parallel. Sorry. And what that means is this has got this resistance here of, let's say, X, and this has got this resistance here of X plus Y you've added onto that. So when you're pulling loads, the bulk of the load will pull through here, and when this is pulling down, this will start pulling through here, or onto here. So what that means is this battery will pull down first, and this battery will pull down second. So this is actually the wrong way of wiring batteries. So let's see this one. Oh, that works. So the way I did it on Vernon's boat is I adjusted it so effectively it went like that, and I went like that, and then we basically got that there and that there. So if you look in terms of the current flow of this now, how it's changed, is you come in here, and you come out here, and out you go. So it means that basically, that's that current path there. If it then goes through the other battery, and back over here, come out, the short path. So the path between these two batteries is now evened out between these. So normally these two batteries, these two cables here, you should try and do equal lengths, but that's not that critical anymore because you've done it. So you force it that all the current is forcing through the batteries, evenly through the batteries. And with Vernon's boat, where it was, this and this were over the same side. So this battery was over here, so that battery went straight to the bar. And you had 1, 2, 3 cables going over across the boat. So that was my 3 cables, which would have confused people there. So that was basically my neutral. I would have said neutral return, and I would have said negative parallel, and I said positive parallel. That's what I was referring to, these cables here. That's just what I call them, as parallel. So that is the correct way of doing it. There's other ways of doing it. Another way you could do it is you go there, and you go here. So that's assuming that's a bus bar. And then you go there and there. But when you do this way, you want to keep that equal to that. And you want to keep that equal to that. So that's a bit of old mathematics. Well, this equals that. Problem is, in some boats, it's very hard to do this. So the way you can cheat to do this is, let's say this is a longer run because it's over somewhere you can't get these two barriers together. Where this cable is you'll make this cable equal this length here. So you'll just spool up the cable. It will look messy, but this is the better way. That's how you would get them together. So if you've got banks where they're split, divorced, or separated, and you've got a long run there, the shorter run, you do it last, and that's where you waste away your cable into it. So if this is 9 meters away, which if you did 9 meter run, that'd be very bad install, but I have seen them like that. This cable here to the bus bar will be 9 meters as well. So that'll be 9 meters, and that'll be 9 meters. And you'll have this coil of wire in the battery box or somewhere near it, which will simulate that. The other way you could do it is you could try and work the maths out and reduce the cable sizing on this to that and calculate resistances, but that's a hard way of doing it, and you could potentially be a cable size where it's undersized for the loads. So easy way, work out your longest length, calculating your voltage drop and your current requirement, and then your shortest battery will be the same length as that with just a lot of wastage of cable on it. So yeah, so hopefully there's a bit of information. If people are more so interested, drop in some comments and I'll do some more videos like this on fusing or 24 volt and so forth. Thank you very much for your time.